Hello, my name is Chris Hanley. I'm the Geotechnical Engineering Department Manager for Terracon Consultants. And Terracon Consultants is a nationwide engineering provider. We do environmental engineering, geotechnical engineering, so relating geologic characteristics to engineering. And we also do construction materials testing, which is checking to make sure that the materials and the processes used in construction are proper and according to the plans and specifications. So, like I said, I work at Terracon. I'm a geotechnical engineer and I'm a licensed professional engineer in the states of Arkansas and Texas. Geotechnical engineering, like I said, is sort of the melding of understanding geology and then applying that to building construction through engineering. And what we do in geotechnical engineering is typically a three-step process. Number one, we go out and do field reconnaissance. So we will go out and look at soil and rock conditions. We may map rock cuts. We may map the bedding planes of rock. We'll typically do some soil borings and rock borings and obtain samples of soil and rock. We may actually do some coring down into the rock and determine the strength and hardness of the rock. The second phase of what we do is laboratory testing. So we bring the recovered samples in to the lab and we run a battery of tests to determine the types of soil and rock materials we have, their engineering properties, their geologic characteristics. And then the third phase of what we do is we do engineering analysis and write a report. So we take the geologic information that we've obtained and we do engineering analysis. So once again, we're combining understanding of the geology with engineering to give us some practical results that we can use for building construction. So those are kind of the three steps that we do. So I understand today you've been working with Allie, who's a good friend of mine, and you've been talking about the Mohs hardness scale. So a couple of ways that's important in a practical sense are, number one, it's a quick, easy way to identify different types of rock. So when we're in the field and even in the lab, we may not have time or money to do a in-depth analysis of different types of minerals and different types of rock to understand what those are and what their constituents are. But the hardness scale gives us a quick and dirty way of, determining what minerals are in a general sense very quickly and gives us a lot of, ability to just use that information right off the bat. The second thing is that hardness is very relatable to a lot of different engineering properties. So a few things that would be relatable to is erosion, strength, and then also slope stability when we're talking about excavations and basements and that type of thing. So first of all, when we're talking about strength, obviously the harder a rock is, the stronger the rock is. So we can just use that quick correlation between hardness and strength to determine how much load a particular type of rock can support. So if we're building a dorm, we may want to determine what type of foundation we need, and knowing the hardness of a rock can give us a very quick, easy way to determine how much load the foundation can support for the dorm. Like I said, the second thing, hardness is directly related to is erosion capacity. So obviously, the softer a rock is, the more quickly it's going to erode when subjected to elements such as wind, rain, and mechanical abrasion, such as like a car traffic. So a good example of that would be a gravel parking lot. If you put a real soft rock in a gravel parking lot, like say a talc or something like that, it's going to get eroded rather quickly and it's not going to last very long. But if you have a hard rock, such as a granite, for example, you're going to be able to have a very erosion resistant material that cars are going to be able to travel over for a long period of time without it becoming eroded. So it's going to extend the life. So that's one way that hardness is directly relatable to engineering design. And then the third thing that we're talking about here is kind of it's related to strength, but we're talking about slope stability. So if you cut a excavation into a rock, we want to know how stable that excavation is. And this is useful for, say, if we're going to put a basement underneath a building, we want to know that when we open up the rock, it's going to be stable and stay open. The other example is if we're going to put some type of piping in, so a water pipe or a sewer pipe, and you're going to have to be cutting into rock. So first of all, you're going to want to know if that rock is stable when you cut into it. But the other thing is that, when you're talking about this as far as construction goes, you can imagine, digging in soil, so sand and clay is going to be very easy, and digging in a soft rock is going to be a little harder. You might do it with just a traditional backhoe or a bulldozer or something. But if we've got a very hard rock, we're going to either need to use some type of a rock saw or a jackhammer or potentially explosives. So um, your construction costs and your construction methods are going to be highly driven by the hardness of rock. So those are three quick ways where interpreting the hardness of a rock, so the geologic characteristics of a rock, are going to have engineering implications and construction implications. So anyway, I hope that makes sense, and I hope you've enjoyed your time with Allie today. And if you have any questions, let Allie know, and she can pass them along to me. And y'all have a good afternoon.